It always sounds very complicated.
Yeah, so what stands out?
This.
Yes, okay, this is what?
I'm not sure if it's completing the square or...
It's one of those long expansion ones, yes, because see, they said the coefficient of x squared and x to the 3. That's what they want. In the expansion of that. So see, expansion means multiply this out.
So how would I identify that this is an expansion question because of this?
Because they said so. And then they said are A and B respectively. So A is the coefficient of what? X squared. B is the coefficient of what? X to the 3. Make sense? Okay, so let me do that and then you can see expanding it. Okay, so question 1. Expand, let's write it down. 3 minus 2x to the 6, right?
Yeah.
Okay, it's not too bad. Not as long as the other one we did last time. Actually, that other one was crazy. It's like, what, was 8 or 12 or something. That was hectic. Okay, so best way of expanding this, group them in pairs. Okay, so let's write down 6 of them, but I'm going to group them in pairs. Because then I only have to do the calculation once, and I can duplicate it. Do you agree? Okay, that's the easiest way of doing this.
So first write them out 6 times, eh?
Yes. Just so you can see them all. Alright, so I'm going to use color. Right, so I'm going to group those two, those two, those two. Right, so I only have to do the multiplication once, and then I can just put it there. Okay, so let's multiply that out once. 3 times 3 is 9. Minus 2x times 3 is minus 6x. Minus 6x minus 6x is minus 12x. Minus 2 times minus 2 is plus 4x squared. There's the term, see? And now I can just write that down again. Right, can I group now? No, I can't because I don't have pairs. So now I've only got 3 terms left. So here I would just multiply those 2 together and then multiply into the other one. So let's do that. Multiply those 2 together. Okay, so 9 times 9 is 81. 9 times minus 12 is minus 108. Okay, 9 times 6 is 36, plus 36. Okay, so I've taken this and I've multiplied out into there, into there, into there.
But yeah, we did FOIL. Okay.
Well, this you also multiplied. I multiplied this, then I multiplied this, then I multiplied this, and then this. Okay. Same thing, just multiplying out. So here, 9 times 9, 81, 9 times that is that, that times that. Okay, so now I need to go again. Minus 12x times 9 is minus 108. Minus 12 times minus 12 is plus 144. Minus 12 times plus 4 is minus 48. X to the 3. Okay, then we need to multiply this one out, the last one. That times that times that times that. 4 times 9 is 36. 4 times 12 is 48, so minus 48. X to the 3. Then that one times that one is 16. X to the 4. Okay, that's it. Close that bracket. And then that's all multiplied by the 9 minus the 12x plus the 4x squared. Okay, so those two multiplied gave me that big thing, and then equal to that. Okay, so let's neaten up that big, long thing. 81 will stay there. I'm just neatening up this and that. X, do I have any other x's? No, I don't. So it'll be minus 216x. Okay, here I've got an x squared. Here I've got an x squared. Here I've got an x squared. Calculator. There we go. Okay, so 36 plus 144 plus 36 is 216. X squared. Okay, so x squareds I've done. Done. X to the 3's, I've got 2 of them. So 96 x to the 3. And then I've got 1 x to the 4. Okay, so there's the bracket neatened up. Okay, so now because the question specifically asked me for what? For the coefficients of x squared and the coefficient of x to the 3. Am I going to worry about anything that doesn't give me x to the 3 and x to the 2? No, I'm not. Okay, so to save time, so you don't spend like 20 minutes on this one question, let's do the check now with the other thing. So next line. Okay, so I'm first going to go with 81. 81 times 9 doesn't give me an x squared or an x to the 3. Ignore it. 81 times 12x doesn't give me an x squared or an x3. Don't want it. 81 times 4x squared does give me a squared. So what is 81 times 4? 81 times 4 is 85. No, that's plus. 81 times 4 is 324. 324x squared. Okay, now let's go with this one.
So it was 81 times
81 times this.
So we're going to do them into all of them.
No, because the question only wanted...
But what gave me this? 81 times 4 to the x squared.
Times that one. Okay, because I only want x squareds and x to the 3's, because that's what they asked me for. So there's no need to make like this massive page of long numbers. I mean, we did that with the other one, but that took long. So I'm saving time now. I'm just looking at what I need. Okay, now I do this one. Minus 216x times 9. That gives me an x. I don't want it. 216 times this does give me an x squared. So I want that. Negative 216 times negative 12 gives me positive 2592 x squared. Okay, this times that will give me x to the 3. Minus 216 times 4 gives me times plus 4. It's plus, eh? Yeah, it's plus 4, not minus. So plus 4 gives me negative 864 x to the 3. Okay, so now I've looked at those first two. Let's carry on. Let's change the color. Let's use blue. Okay, now I'm looking at this number. Okay, 216x squared times 9. That will give me an x squared. 216 times 9 gives me plus 1944 x squared. Okay, this one times this will give me an x to the 3. Okay, so 216 times negative 12 gives me negative 2592 x to the 3. Okay, then I've got this one, x squared times x squared is x to the 4, don't need it. Okay, now I'll go next one. Yeah, let's put a little x here. Okay, this multiplied by all of that. This times 9 will give me an x to the 3. So 96, negative 96 times 9 is negative 864 x to the 3. Okay, this times that gives me x to the 4, don't need it. This times that gives me x to the 5, don't need it. Okay, and then the last one, 16x to the 4, it'll give me x to the 4 or more for all of them. That's it, the end. Okay, so let's wrap up and add up all of those. Okay, so let's underline the x squareds. Here's an x squared, here's an x squared, here's an x squared. Okay, let's add up those figures. 324 plus 2592 plus 1944 gives me 4860 x squared. Right, then we need to group all the other ones together, the x to the 3's. So negative 864 minus 2592 minus 864 gives me negative 4320 x to the 3. Okay, they want a over b. Okay, so another step. What was a? What was b? A was x squared. So this was a. B was respectively that. That's b. Okay, they wanted find the value of a over b. Alright, so a over b is going to equal 4860 divided by 4320.
What did we say, x squared and x cubed? No.
No, because the a is the coefficient.
Oh.
It's the number in front. Okay, 4860 divided by 4320 is 9 over 8. Same answer. Oh, I forgot the negative. There's a negative there. See? Minus here. Let's just put a minus in. Done. Same answer. Yeah, see? Okay. They just give answers, they don't give workings. Okay, next. Question 1 done. Right, so you see that was quicker than adding up all the stuff. So the point I was trying to make last time when we did that long one is exactly what I did here. The ones that don't give you the squares or the 3's you can ignore. Okay, if it's x or if it's x to the 4 or 5 or 6, ignore it. Only want squares and 3's.
Yeah.
Good. 2.
Okay. Thank you. Relative to an origin O, the position vectors of points A and B are given by, and angle AOB is 90 degrees. Find the value of P.
Okay, this is similar to what we did previously. We need your vector notes again. Just the rule. Which rule are we using here? Is this 1 or is this 3? Is this on its own, eh? No, it's
2.
2, 1. Okay. Alright, so you go to your vector notes. Only for vectors do we use the vector notes.
Yeah.
Vectors aren't used anywhere else. It's totally standalone, it's totally separate. It has its own rules altogether. Okay, that's the only problem with this section, is it's standalone and it's separate. So if I have something like this, then I have to follow those rules. Okay, it's the one where we had that perpendicular. We looked at it last time, I remember.
So you have this relative to O because it's 90 degrees.
Yes.
Perpendicular. Okay.
Okay, so find that perpendicular vector one. Same as what we looked at last time.
There's position vector.
There, perpendicular vectors. There we go. Okay, what did we do here? We multiplied there. See, A times B. Multiply those two together, add them up. Okay, same as what we did previously. It's actually in the last past paper. You might even have it there. Okay? There we go. Perpendicular rule. Same thing. Okay, good. Alright, so what must we do then? We need to multiply them out. So basically, it's OA vector times OB vector.
So because it's perpendicular, we times.
So brackets, it's 3 minus 6 and P. And then multiply that by what's the other vector? 2 minus 6 and minus 7. Okay, so when we multiply those vectors out, we multiply the two numbers and we add them all up. So that's going to equal 3 times 2 is 6. Minus 6 times minus 6 is minus 36. P times minus 7 is minus 7P. Okay, what did they say this was equal to? Equal to 0 because it's perpendicular. See there?
Yeah.
Your notes equal to 0. Okay. Right, solve for P. 7P equals 6 minus 36 is minus 30. P equals minus 30 over 7. Did they simplify it any further? Yeah, it looks like they did. Oh, hold on. I've made a mistake with the sign here. Negative times a negative is a?
Positive.
Ooh, mistake. Sorry. Okay, let's fix. Bad arithmetic. Use the calculator just to make sure. 6 times 6 is 42. Well, 6 plus 36 is 42. Okay, 42 divided by 7 is 6. That's better. Okay, same answer as what they've got. Okay.
So yeah, we didn't have to use this cos theta thing. We just had to know that it was this basically.
Well,
See,
cos
yeah,
theta, cos 90 is what?
1.
No, yes.
That's why they say equal to 0. Okay.
That was just the theory. The theory is okay. Obviously, that it's nice to know, but just remember that rule. This is what I actually wanted.
Yeah.
That's what I wanted. The one vector times the other vector equals 0. Yeah, that was the key. Okay, 2 vectors multiplied gives you 0. Okay, next one.
The point C is such that OC is equal to 2 over 3 OA. Find the unit vector in the direction of BC.
Okay, so now you go to your unit vector stuff.
Unit vector
Yeah.
is equal to 1.
Good. Okay, if you know it already, that's good.
The length is 1.
So let's apply
Find
that.
the absolute value.
Okay. Right. Good. See, it's same steps. Right, perfect. So let's write down the vector. What is the vector? The point C is such that OC, okay, let's write that down. OC vector equals 2 over 3 OA vector. That's what they say. Find the unit vector in the direction of BC. Yeah, so let's, I like using the textbook because they also had the same thing here.
So we first have to find the absolute value.
Okay.
So would we take this 2 over 3?
I think so. Let's just double check. I'm not too sure what the, if you use the whole thing which is part of it, let's just check. Okay. Okay, vectors was 206. This was the unit vector, so 216. Okay, here's a unit vector. So if you've got a vector that's like that, it's the absolute value of all the numbers in front of those letters.
Yeah.
Okay, so what were the numbers in front of the letters here?
2/3.
It was, yeah, they want BC, hey? So it's C minus B. So that's you have to subtract first. That was the first step. So 2/3 of A. Yeah, so you do need to simplify. Okay, what is OC? Let's write down the vector. OC was given as?
No. OC is equal to 2/3 OA.
Okay, it's equal to that. That's good. Okay, so 2/3 is multiplied by AO. AO they gave you, which was 3 minus 6 and P. Okay, now we know what P is. Do you agree?
Oh, it's the same thing here.
Yeah, the second part. P is what? 6 from above. That's from 1.
Okay, so OC.
Yeah, so multiply the 2/3 into all of it.
OC. What is that? OC. So is this OC?
Yeah, OC just carries down. OC, OC, OC.
So OC is equal to 2/3. 3 minus 6. So now we times it in.
Correct. Okay, so 2/3 times 3. The 3's cancel, left with 2. 2/3 times minus 6. It'll be minus 12/3. Minus 12/3 is minus 4. 2/3 times 6. 2 times 6 is 12. 12/3 is 4. There's the vector. Okay, same as what they've got? Yes. There's the answer. Okay, for the OC. Okay, so now you know what OC is. We want to know what BC is. So here they've got C minus B to find the magnitude, okay, which is what you wanted to do, the square root, the vector. Okay, so that's...
So which vector do we find the absolute value of?
Let's check, because they've got 125 here. So 2 squared is 4. 4 plus 4 squared is 16. Plus 4 squared is 16. Is 36. No, you can't use that one. So you need to find the other one. So they've gone with BC here. We need BC. That's why we need to work out BC first. Okay, so BC requires that other bit of information. There's a formula when you have A, B, and C, hey? Those are position vectors. I think you could probably even just look at your notes for the position vectors. Yeah, the textbook uses P and Q, P, Q, and R. Basic unit vectors. Okay, here position vectors. There we go.
So is this what the diagram would look like?
The diagram would look like this actually, like that. O, B, O, C, O, A.
Okay.
Like that.
So O.
This picture on page 210.
O, C.
No, exactly like that.
O. And then this would be. What is this?
What is?
What is this line? AC.
Yeah, that'll be AC or CA. Well, if the vector's upwards, it's AC.
So they say the point C is such that the point C is such that
OC, yeah, so OC, that one
is equal to OA.
Is equal to 2/3 of AO.
Okay.
Yeah, that you've got. Okay, you've worked it out. Now they say find the unit vector in the direction of BC. So
where's BC?
Yeah,
From
see there's
here to
BC.
here?
Yeah, BC is there to there. Okay, so they want you to find that, having been given what you've got. So you've got OC, you've got OC, and you're working out BC, right? So it would be the C vector minus the B vector, because they're in different directions. In the direction of BC, because remember, if it's in that direction, they're like this. So you have to minus, not plus. Okay, because it's the direction. Okay, it's the other direction. See, that's B and that's A. See, these vectors are sloping this direction and that direction. Where is E going? E is going in that direction. Okay, so it's minus. See, it's minus there. When it's like this, it's plus. See, why is this plus? Because see, there's the vector that direction, that direction, that direction, same direction. Okay, so we need to go with C minus B. What did they do? Use C minus B, yes, see, same thing. Allow for the vector, and then they have to show the answer. Okay, alright, so the C, OC minus O, the two vectors subtract.
So how do you know when to subtract? Just explain to me.
Because you subtract when this line,
So
which direction is
it's
this
going
line?
left.
In the opposite direction, not always left, just in the opposite direction. Okay, so how many vectors do I have here? 1, 2, 3. Okay, B is up, A is right, E is left. Okay, so if I wanted E, because E is left, I'm going to take that vector minus that vector because it's that direction. Okay, if it's in the same direction, like here, O, B, O, C, O, A, up, right, right. Okay, to get the C, C, which is this, would be the same as that vector plus that vector. It's the sum. It's the adding of those two vectors to get you that one. Okay, it's like a force. So if the wind is blowing this way and there's another wind blowing that way, then you're going to add the two vectors to get that wind that way. Yeah, so see, it's like the wind is blowing north and the wind is blowing east. Okay, this would be like northeast, right? So it's the sum of the two vectors. Okay, so for this one, it's the opposite because they wanted the direction BC. So see, BC would have been what you drew here, BC.
Okay, so I'm just going to draw this here.
Okay.
So to find BC, it is A minus B.
C minus B, C minus B. Yeah, C minus B. Okay. Alright, but now we need to get, did they give us B? Where's the question? They gave us, they gave us OB. They gave us OB, hey? Yes. Alright, they gave us OB. Okay, so you've got OC, right? There's OC. Okay, OB is given in the question. Let's write down OB as well. What is OB? Just go back to that page. OB was 2 minus 6 and minus 7. That's from the question. Do you see that? There. Okay, so what is the vector for, what do they want? BC, hey? Yes. So if it's BC, okay, BC on your diagram is the C minus the B. Okay, so two. So in other words, this vector minus this vector. Ooh, put a minus in between. Okay, 2 minus 2, 0. Minus 4 minus minus 6 is plus 6, so that's plus 4. No. The arithmetic there, not so great. Minus 4 plus 6, 2. And then minus and minus plus is 11. Okay.
Okay. That'll.
What else did they want?
Find the unit vector in the direction of BC.
Okay, now we do what you did, square root.
Okay.
Okay, so now you can square root 0 squared plus 2 squared plus 11 squared.
So this is the absolute value of BC.
Yeah, 4 plus 11 squared is 121, is root 125. And the unit vector would just be the 1 over. Okay. Now, so the last two steps are quite easy to do. And then you would have unit vector would be 1 over. So unit vector 1 over root 125. And that's it. Yeah, so the challenge was applying the rule. We just had to draw the diagram just to get the right picture. And then we got it eventually. Okay. In the direction BC. Yeah.
Why do you say, I know that the 1 is the length, but why do you say 1 over 125?
Because it was the unit vector. If you go back to the theory, let's show that. There, see basic unit vectors. See, basic unit vectors is that 1 over 0, 0 over 1. It's like a whole inverse story. See, so you have, okay, this was the addition, this was that was the algebra. Basic unit vectors. This is not component vectors, this is a unit vector. See, the vectors 1, 0, and 0, 1, which appear in the last expression, are called basic unit vectors in the x and y directions. They are denoted by the terms I and j. So I and j is just the measure, okay, the magnitude, the size of the vector. See, here's the position. Anything else in the notes? Vectors in 3 dimensions. Magnitude of the vector, we did the magnitude, we looked at this. So there's the square root. Scalar products. There must be a rule that supports that. The only one do you have anything in your notes?
No, all I had was like get the unit vector, multiply the inverse of the modulus times the vector.
Okay, that's fine. That's your other notes in this. Just go to your unit vector. What did you write here?
Exactly the same thing.
Multiply the modulus by the vector. Get the unit vector.
Did we do that?
Yes. We just see here unit vector.
No, we only got the.
Oh, the inverse times the vector. Naught. Yeah, we haven't finished it. 0, 2, and 11. Yeah, that is the last step. That's what the last step said, right? Multiply inverse of modulus, which we got, times the vector. Okay.
And that will give you the length.
And that'll give you the final answer. Okay, that you'll have to work out.
When it's like this, should I make it a decimal or?
Yeah, write it as a decimal. It's better if you're writing it as numbers.
So it's 0, 0, 2, and 1.
Yeah, they just left it as that. They didn't go further. Right, is that it? Okay, now we've got trig. Trig is good. You should like trig. Why?
I actually don't like the trig.
You don't like trig? Okay, it's just identities. Right, so let's do that one. It's nice and short and simple. Okay, question, was it a standalone question? Question 3 on its own. Perfect. Okay, this is left-hand side, right-hand side. Why? The word proof is there. Do you agree? Right, let me just write down the question and then you can try it. Or let me do it and then you can check later on when you revise. Okay, cos theta sine theta. Okay, see if you can keep up with the logic. Okay, so I've done it here. Maybe if you want to read through it, you can check it and see. Because once we've done it, with maths, you can always go back and redo questions. 1 plus cos theta equals, okay, well, they use that because that's the left-hand side, that's the right-hand side. Okay, 2 over sine theta. Right, is there anything that I can do on the right-hand side to simplify that? No. 2 over sine theta is the simplest expression you can get. So all you're going to do is you're going to be playing with the left-hand side in terms of sine and cos to get the same thing as the right-hand side. Okay, so what do I see on the left? I see sines and I see coses. I'm happy with that. But I see a denominator. So the first step is to get a common denominator. So sine theta 1 plus cos theta. Okay, so that's the denominator. So denominator there, I need to times it by that. So I'm going to have 1 plus cos times 1 plus cos. Okay, plus 1 plus cos is at the bottom. I've got sine squared that I want, so I'm going to times the top by sine squared. Sine squared plus sine is, well, sine plus sine is sine squared. Okay, there we go. Right, now I've got that. Hey, can I multiply this out? Yes, I can. 1 times 1 is 1. Okay, 1 times cos is cos. Cos times 1 is 1, so then I have plus 2 cos theta.
So are you
multiplying out this times that, this
one
times
in there
that,
and one in there?
times
or
out.
Are you doing FOIL? Like inners, outers?
Yeah, inners, outers, all that stuff. Multiply out. 1 times 1, 1.
First.
Cos times 1
Oh, okay.
is cos. 1 times cos is cos. 2 cos. Cos times cos. Okay. Plus sine squared theta. Do you agree? Okay. So now at the top, what do I have here? I have cos squared plus sine squared. Do I know what cos squared and sine squared is?
1.
Exactly. Okay, so I can make this 1. Let me use a color here just to show you what I mean. But I think you already see it.
Yeah.
This.
That's an identity.
Exactly, that's 1. That's an identity. So now I've got 1 plus 1. 1 plus 1 is 2. So I'll have 2 plus 2 cos theta. Do you agree?
Mm-hmm.
Okay, so next step. Can I just do it here so you can see it? Okay, so then I've got 2 plus 2 cos theta. Okay, over sine theta 1 plus cos theta. Do you agree? Can I factorize the top? Do I have a common denominator? Yes, I have a 2 that's common. So take out a common denominator. If I take out a 2, from the 2 I'm left with a 1. If I take out a 2 here, I'm left with a cos. See, that's normal factorizing. Common denominator. Sine squared theta, 1 plus cos squared cos theta. Okay, what do you notice? This can cancel with that. 2 over.
So there's only really one identity there.
Yes. This one was easy compared to the other one we did.
That's what confused me so much.
Okay. Right, that one's done.
Where's my paper?
Can we do more? Or do you want to take a break now?
I'll take a break now and
Okay.
then